template method allows you to define a template method or skeleton for an operation. The specific steps can then be implemented in subclasses. So suppose we are designing some software that will be installed on a machine that makes hot beverages. At the beginning we just had tea and coffee, but after some feedback from customers we needed to add some more beverages such as chamomile tea. So we started out pretty simple, making a separate class for each hot beverage. But as the number of beverages grows, we see a lot of code duplication. So if we have a look at this example here, we have tea, coffee and chamomile, each with a make beverage method. And we can see inside of the make beverage method we are calling the boil water method and a pour into cup method. And these methods are actually, or these steps are used in tea, coffee and chamomile. In fact, they're used in all beverages. All hot beverages require boiling water and pouring that water into a cup. But we also have some methods that differ between the different beverages. For example, the brew method may require different amounts of time, and the add condiments method will differ as well, because different beverages will require different condiments. For example, tea, it might be possible to add, say, milk and lemon, whereas with coffee it may be possible to add cream. So one of the issues is with this solution is that as the number of beverages grows, we see a lot of code duplication. So we are duplicating this boil water and pour into cup logic in each of the beverages. And we also have no way of ensuring that each class follows a particular structure, which means that the client code will have to include lots of if-else conditional statements to pick the proper course of action depending on the particular beverage class. So I have made a tea class, and we're just going to add some methods for boiling water, pouring the water into the cup and brewing the tea. So we also need a method to see if the customer wants condiments, and then we need to add those condiments to the beverage or to the tea. So let's create a method called add condiments. And what we're going to do here is we're going to check if the customer wants condiments. So we're actually going to create a method called customer wants condiments. And if they do, then we're just going to add some lemon to the tea. So let's create this customer wants condiments method, and this is going to be a method that returns a Boolean value. So what we're going to do is we're going to log to the console a question. So we're going to say, would you like lemon with your tea? And the user is going to be able to input yes or no. Okay, so now what we need to do is we need to read the user's input from the console. So we can say console dot read line. Okay, and then we can simply return the input dot to lowercase. So we take the user input, so it should be either a Y or a no, and we make it lowercase, and we check if it is equal to yes. So if the user inputted Y for yes, then this will return true, meaning that the customer wants condiments, and so we add some lemon to the tea. Okay, so pretty straightforward. So now we just need to make one final method, and that is going to be called make beverage. And this is where we basically call all of these methods in the correct order to make the tea. So I'm just going to paste those in to save some time. Okay, so we boil the water, pour it into the cup, brew the tea, and then check if the user wants condiments, and if so, we add them to the tea. So pretty straightforward. So let's actually go ahead and test this out. So let's clear out our program.cs file, and we're going to create a new tea object. And we're going to call tea.makeBeverage. Okay, so let's see how this works. So we have boiling water, pouring water into cup, brewing tea for 3 minutes, and then it says, would you like lemon with your tea? So if I input Y, whoops, so if I come into the console, Y and enter, let's see what we get here. Okay, so it says adding lemon to the tea. So this is working correctly. If I say put no, so N, let's see what happens. Okay, nothing happens, so that's perfect. Okay, so this is working correctly. So now let's also go ahead and create a coffee class for creating coffee beverages. So okay, so let's now also create a coffee class for making coffee. So what I'm going to do is I'm just going to paste in these methods for making coffee just to save some time, because it's largely the same as the tea class. So as you can see, we have boil water, pour water into cup. So these methods are identical to the methods in this tea class. And then we have the brew method, which brews the coffee for 5 minutes. So slightly different to brewing tea. And we also have the add condiments, where rather than adding lemon, we add cream to the coffee. So we can see that we have two methods that are identical to the ones in tea. So the issue is that the more of these beverages that we create, we're having a lot of code duplication. So there are two good ways to solve this issue of code duplication, and they are polymorphism and inheritance. So first of all, we're going to use polymorphism, which actually leads to a design pattern that we covered earlier. So let's see if you can spot which design pattern that is. So here we have our solution using polymorphism. So here we provide a common beverage interface to force all concrete beverages to follow a specific structure. We then have a beverage maker class that manages preparing the different beverages. And this beverage maker class includes the common operations for making all beverages, such as boiling water and pouring it into a cup. And it also includes operations specific to each beverage, but these operations are delegated to each of the concrete beverages. So this beverage maker actually talks to or is coded to a beverage interface, meaning that we can use polymorphism. So we can pass different concrete beverages into the beverage maker, and then this beverage maker can simply call beverage.prepare. It doesn't actually care about the specific concrete beverage class that's been passed to it. Because it's coded to an interface, it can just call prepare. So we are essentially using polymorphism to make things nice and flexible. And so now when we create a new beverage, so if we get some more feedback from a customer that we need to, and we want to add a new beverage, we want to start selling a new beverage, then we can just create a new concrete beverage class that implements the beverage interface. Okay, and we only have to include in these concrete classes code that is specific or unique to that beverage, because the sort of shared code is placed inside of this beverage maker class. So by using polymorphism here, we have inadvertently used the strategy pattern. So you can see here, this is the strategy pattern UML, where our context object is the beverage maker, and we have a strategy interface, and in our case this is the beverage interface, and then our concrete strategies are our beverages. Let's now implement this strategy pattern or polymorphism solution into code. So first of all, I'm going to create an interface called beverage, and I'm going to add a prepare method. Okay, so now let's create our T class that implements the beverage interface. So this beverage interface is kind of like our command interface, our strategy interface. Okay, and then we're going to create our concrete strategies, which are basically our concrete beverage classes. So first of all, let's create the T class, and this is going to implement the beverage class. So let's implement this interface, and what I'm going to do is I'm just going to copy and paste in some of the methods that we had before. So we had the brew method and the add condiments method, and also the customer wants condiments method. So let's add those in, and these are the kind of methods that are unique to this specific concrete beverage. Okay, so now what we can do is we can, inside of the prepare method, we can call brew and add condiments. Okay, so if you can remember before, if we go into T, beforehand we also had a boil water and pour into cup method before we called brew and add condiments. But now we are going to create a separate class so that this kind of these two steps can basically be shared between all of the beverages to reduce code duplication. So let's continue, and let's create a coffee class. So this is another sort of concrete strategy class, and this implements our strategy interface, which is the beverage interface. So if we implement that, and I'm just going to copy and paste the brew, add condiments, and the customer wants condiments methods into this class to save some time. And let's see, what did we do here? Okay, so I think that's okay. Yeah. Okay, so now in the prepare method, we can call brew and add condiments. Okay. So we can also do the same for chamomile. So let's create a chamomile class. So this is another concrete beverage, and this needs to implement beverage. And I'm just going to for chamomile, let's say chamomile is very simple, because all we really have to do with chamomile is put the tea into the cup and brew it. We don't really have to add condiments to chamomile. Okay, so we can just call the brew method. So let's create a brew method, and let's just brew chamomile for 3 minutes. Okay, so to prepare chamomile, all we need to do is brew it, basically. That's the only specific step to chamomile, brewing it for 3 minutes. So now we can create our beverage maker class, and this is going to contain our sort of shared code. So first of all, we need a field for referencing the particular beverage that we are going to be making, and this is coded to the beverage interface, allowing us to pass different types of beverage into the beverage maker class. And then we're going to need a constructor where we set the beverage, and we also need a set beverage method so that we can easily change the beverage that we want to prepare. And in here we are just going to set beverage equal to beverage. Okay. So next up we need a boil water and pour into cup methods. So let me just copy and paste those in. So these are our shared methods or shared steps. Every single beverage we have to boil some water and then pour it into the cup. So then what we can do is we can have a method called make beverage, and in here we can have our common operations, so the operations or steps that every single beverage has to follow, and those are boil water and pour into cup. And then we can call our unique operations by simply calling beverage dot prepare. And as you can see, our beverage maker needs no specific knowledge of the particular beverage that it's preparing, because we are coding to an interface using polymorphism. We can just call the prepare method, and it will call the prepare method on any of the concrete beverages. Okay. So now if we go into a client and show how a client might use this solution. So first of all, we would create a beverage maker. And in here we pass the beverage that we want to make. So let's say we want a cup of tea, and we have the beverage maker dot make beverage. So let's see how this works. Okay, so boiling water, pouring boiled water into the cup. So those are our shared methods, which are actually inside of the beverage maker class. So you can see here, when we say make beverage, we call these common operations from within the make beverage, within the beverage maker class, and then we call the unique operations. So in this case, we brew the tea for 3 minutes, and then we ask the customer if they would like lemon with their tea. I do, and I get lemon in my tea. Perfect. So let's say we want to now make a coffee. So we say beverage maker dot set beverage, and we can say new coffee, and we can call beverage maker dot make beverage. Now this time it will call the two shared methods, and then it will call the methods specific to making a coffee. So first of all, it's making the tea, so let's do the tea, and then it makes the coffee, and it asks if I want cream with the coffee. Yes, and let's see, it adds cream to the coffee. So this is working perfectly. So let's just summarize what we have done here. So inside of beverage maker, we define the common behavior for making a beverage, and that is boil water and pour water into cup. And we have an interface called beverage, and this has a prepare method. And we also have our concrete beverage implementations for chamomile, coffee and tea, all of which implement the beverage interface. And this allows us to treat all beverages the same way in the beverage maker class. And from here, from the beverage maker class, we specify the beverage when we create the beverage maker object, or we can set the beverage here. And then we are delegating or forwarding the execution of tasks related to making a specific beverage to a concrete beverage object. And this is the strategy pattern. So we've just solved this problem using polymorphism, which actually led to us using the strategy pattern, but we could also solve this problem using inheritance. So tea, coffee and chamomile have things in common. So we can create an abstract class called beverage that implements the prepare method. But after we've boiled the water and poured it into the cup, what happens next is unknown in the abstract beverage class, as it depends on the particular beverage. And these beverage specific steps will be determined later on when the beverage class is extended by the concrete classes. So we can provide a base abstract class called beverage that contains all common operations for making a beverage. And we can provide methods called brew and add condiments, which can be implemented or overridden in the concrete beverage classes. So you can see here we have our beverage class with a prepare method, and you can see we have the brew and add condiments methods, which are sort of dulled out in grey, which is implying that they are not implemented in this beverage class. They are abstract methods which need to be implemented in the concrete tea, coffee and chamomile classes. So you can see here this prepare method is known as a template method. So it's providing a template for the steps involved for preparing a beverage. So we have the boil water and pour into cup methods, which are defined in the beverage class itself, okay, because these are our shared methods that are used by all beverages. And then we have brew and add condiments, which are to be defined later on when this beverage class is extended. So this prepare method is acting as a template method, okay, and this is known as the template method pattern. So the beverage class has a template method that provides the common setup and structure for preparing a beverage. And here's how the template method pattern is shown in the Gang of Four book. So we have an abstract class with a template method, a public template method, which calls the some abstract methods in a particular order. Okay, so then we have our concrete methods, our concrete classes that implement those methods, and the template method will call those methods in a particular sequence. So we have an abstract class with a concrete implementation of the common shared template method, and the abstract methods that will be implemented within the concrete classes can be used to alter the behavior of the template method. And we can also give the primitive operations a default implementation and leave it up to the subclasses to either take them as they are or override them. In this case, we refer to these methods as hooks or hook operations. So you can see here in this abstract class these sort of methods that are to be implemented in the concrete classes are not dulled out anymore. So we're providing a default implementation for these methods, and it is now optional in these concrete classes whether they are sort of overridden. So we have method 1 and method 2 here with default implementations within this class, and we've just decided in this concrete class in particular, in this example, we're just overriding method 1 and leaving method 2 to its default implementation within the abstract class. So we're not going to bother to override it, we're just going to take it as it is, and we refer to these kind of methods as hooks. So let's now implement the template method pattern in code. So here we have our base beverage class, and currently we have our template method with all of the steps involved in creating a beverage. Now, if you remember, the boil water and the pour into cup steps are shared between all of the concrete beverage classes. So we can actually implement these two steps inside of this beverage class. So let's copy and paste those in just to save a little bit of time. So here we boil the water and pour into the cup. So those are the first two steps that every beverage has. Now in this template method, we can now provide we need to provide a brew and add condiments methods. So I think for brew, what we will do is we will make it a virtual method. So in fact, actually we will make it an abstract method, which means that all subclasses must implement this brew method. Okay, so every concrete brew needs to specify how long to brew the beverage for. So what we'll do is we will create a protected, an abstract void brew, and it will just be like this. So we must provide this brew method inside of all of our concrete beverages. Now we can see that we are getting an error because this class now needs to be an abstract class because it has an abstract method. Now let's also create this add condiments method. So the add condiments method, what we're going to do is we're going to create this method with a default implementation. So we will say protected virtual, meaning that it can optionally be overridden in its subclasses. And what we're going to do is we're going to provide a default implementation of an empty body, which basically means that we don't add any condiments by default. Okay, so that's our base abstract beverage class. So now what we can do is we can create the concrete classes. So let's start off with the T class. And T needs to inherit from beverage. And we also need to implement this abstract class. So the only method that we have to implement is this brew method because it's an abstract method. And in here, we can just say brewing tea for 3 mins. Okay, and then optionally we can provide a add condiments method here, so we can override this default implementation. So this is essentially a hook method. So I think what we're going to do is we'll just copy this from inside of what we did before. So let's copy and paste that in, and what we need to do is we need to say that we are overriding this method from the beverage class. And we have an error here, let me check. So we need to make sure that this is protected to match the method signature from the beverage class. Okay, so that all looks okay. And just to save some time, I'm not going to make the coffee class, but I'll just make the chamomile class because that is a little bit different to the tea class. So chamomile. And again, we need to inherit from beverage, and then we need to implement the abstract class. So here we'll just we'll say brew chamomile for 3 mins, and this is all we need to do for the chamomile class because chamomiles don't have any optional condiments. So that is everything we need to do there. So let's now have a look at how a client would actually use this solution. So if we go into our client and we create a tea beverage, and let's make sure we're using the correct namespace here. So this is the template method, and we can just call tea.prepare. And then run this program, and we can see we get these are the 2 shared steps, the boiling the water and the pouring into the cup. Then we have our sort of concrete class specific logic here, brewing the tea for 3 mins, and it asks us, would you like lemon with your tea? And we get lemon in our tea. And then for the chamomile, we can do the same thing pretty much. And there are no optional condiments, so it just makes the beverage automatically without us having to answer any questions. So this is a nice and simple solution for clients to make beverages. All beverages provide a simple API, a simple and consistent API with a prepare method, and the rest of the complexities are abstracted away as the clients require no knowledge of those complexities. Let's now have a look at the differences between the template method pattern and the strategy pattern, as we've just previously used both to solve the same problem. So you can use the template method pattern when you have an algorithm with a fixed structure, but with certain steps that need to be customized or implemented differently by subclasses. And this pattern is ideal when you want to define a common algorithm skeleton, or in other words the template method, in a base class and allow subclasses to selectively override specific steps to provide their own implementations of those specific steps. And the template method pattern is suitable when the overall algorithm structure remains consistent, but specific parts of the algorithm can vary based on different requirements or contexts. And for the strategy pattern, you can use the strategy pattern when you want to define a family of interchangeable algorithms or behaviors and encapsulate each algorithm into its own class. And the strategy pattern is ideal when you need to dynamically select and switch between different algorithms at runtime, depending on the situation or context. And the strategy pattern is suitable when you want to decouple the client code from specific algorithm implementations, allowing for greater flexibility and extensibility. So in summary, if you primarily need to customize or override specific steps of an algorithm while keeping the overall structure intact, the template method pattern is a good choice. On the other hand, if you need to encapsulate entire algorithms or behaviors as interchangeable components that can be dynamically selected or replaced, the strategy pattern is probably more appropriate. So both patterns have their strengths and are used to address different design scenarios. The choice between them depends on the specific requirements and design goals of your application. So when should you use the template method pattern? You can use this pattern when you want to allow clients to implement only particular steps in an algorithm and not the whole algorithm. It's a good pattern to use when you have a bunch of classes with the same logic or algorithm, but with differences in a few steps. So if the algorithm changes, it only has to be modified in one place, and that is the base class. So the pros and cons of the template method pattern. So the pros, we can reduce code duplication by having the sort of shared logic or methods in the base class that can be inherited. And clients are only allowed to modify certain steps in an algorithm, which reduces the risk of breaking clients if the algorithm changes. And some of the cons are that some clients may be limited by the provided template, and template methods can be hard to maintain if they have a lot of steps.